This is part 3 of section 9.7. We want to solve this inequality, okay? The first thing we would need is a 0, and I'd move this over here, and then I'd have to multiply this all out and then factor what I have left. And you can do that, but you're going to get something really ugly, and that's because there's something they hope that you recognize before you go on. Okay, so imagine plugging a number, any number you can imagine, in for x. Okay, positive, negative, huge, small, ugly fraction, ugly decimal, whatever you can imagine. We're going to take this number and we're going to multiply it by 3. Okay, then we're going to take that answer and add 5 to it. Okay, so we have some number here. It's ugly maybe, it's negative, it's positive, it doesn't matter, right? Now I'm going to square that value. This number inside is either positive, in which case when you square it you get a positive, or it's negative, which means when you square it you get a negative, or perhaps it's 0. Okay, so no matter what number I plug in here, it's going to be a negative squared, it's going to be a 0 squared, or it's going to be a positive number squared, right? Well, when you square a negative, you get a positive. When you square a positive, you get a positive. When you square 0, you get 0, right? So let's look at all these cases. When is a positive number less than or equal to negative 4? Well, a positive number is never, ever smaller than negative 4, so that never happens. That eliminates these two cases. Well, when is 0 less than or equal to negative 4? 0 is never less than negative 4. From the beginning, if you understand what this is always going to be either positive or 0, and that is never going to be smaller than negative 4. So this has no solution at all. Okay? So let's look at a different one. Okay? So I have x squared minus 3x is less than 10. Okay? So I need a 0, so I'm going to move the 10 over to here. That gives me x squared minus 3x minus 10 is less than 0. Okay. Now I need to get this factored. This is the easier type of factoring. I'm looking for two numbers that multiply to a negative 10 and add to a negative 3. That's going to be negative 5 and positive 2. So I have x minus 5, x plus 2 is less than 0. Now set each of these equal to 0. X minus 5 equals 0, or x plus 2 equals 0. Add 5 to both sides, subtract 2 from both sides, and you get x is equal to 5, or x is equal to negative 2. So let's put these numbers on the chart. And I have a negative 2, and I have a positive 5. And then my two factors are x minus 5, x plus 2. Okay. Now I need a number in this region, so a number smaller than 2, I can use a negative 2, I can use negative 3. A number between negative 2 and 5, I can use 0. A number larger than 5, I can use 6. Okay. So if I do negative 3 minus 5, that's negative. Negative 3 plus 2 is negative. 0 minus 5 is negative. 0 plus 2 is positive. 6 minus 5 is positive. 6 plus 2 is positive. A negative times a negative is positive. A negative times a positive is negative. 2 positives is positive. Okay, again, your graph is not always, your chart's not always going to look like this, okay? I'm looking for where this thing is smaller than 0, so I'm interested in the negative region, which is here. So my answer is between negative 2 and 5, and I got ahead of myself by putting the parentheses, but it's going to be parentheses because this does not have an equal to on it. My answer is between these two. And then your answer in interval notation would be negative 2, 5 inside parentheses. Okay, so all the ones we've worked so far have been quadratic. This is a polynomial inequality. If I were to multiply all of this out, I would have a p cubed in it. So it is different. But the basic idea is the same. If you get one of these, they're going to be in a special case for you. It's going to have the 0 already for you, and they're going to give it to you in factored form, or it will be something that we already know how to factor, meaning that you would have a GCF in there somewhere. Because in general, we don't know how to factor third degree polynomials. Okay? Now what we do is basically the same thing. We get a 0, we make sure this is factored as possible, and then we set each factor equal to 0. So I would have p minus 1 equals 0, p minus 2 equals 0, and p minus 4 equals 0. Solving each of these, I get p equals 1, p equals 2, and p equals 4. This works exactly the same way as the others. Your chart's just going to be bigger because you have 3 values. So on my number line, I'm going to put these numbers in order. So I have 1, I have 2, and I have 4. Extend this down, making it a little bit longer than usual because I have more factors to put over on the left. I need to put all of these there. So I have p minus 1, I have p minus 2, and I have p minus 4. And I need a test number in all of these regions. So I have one more region to test. I need a number smaller than 1. 0 is useful. I need a number between 1 and 2. I can use 1.5. I need a number between 2 and 4. I can use 3. I need a number larger than 4, so I can use 5. Okay? Now imagine plugging in your 0. 0 minus 1, that's negative. 0 minus 2 is negative. 0 minus 4 is negative. Now once you start having to deal with decimals or fractions, this is where it becomes really nice that you don't have to do all the calculations. You know that 1.5 is bigger than 1, so when you do that subtraction, you're going to get a positive answer. 1.5 is smaller than 2, so you're going to get a negative, and then you're going to get a negative here as well. Okay? Now 3. 3 minus 1 is positive. 3 minus 2 is positive. 3 minus 4 is negative. Now plug in your 5s. 5 minus 1 is positive. 5 minus 2 is positive. 5 minus 4 is also positive. Okay, so now apply your multiplication rules. And so here we're multiplying 3 negatives together, and that gives us a negative answer. A positive times a negative is positive. Positive times a negative is negative. And then 3 positives is a positive. Are these always going to alternate? No. That happens a lot, but it does not always happen. Okay? So now let's look to see what kind of answer we were hoping for. We want this thing to be smaller than 0, so we're interested in the negative areas. Our graph is negative here and also here. This is less than, so we're going to have parentheses. I need to put 1, 2, and 4 on our graphs. We shade in this region, which is less than 1, so that's right here. And this is going to get parentheses. And then between 2 and 4. So parentheses here and here, and shade there. Your answer in interval notation, you need to describe both of these. This one starts at negative infinity and stops at 1, and they have parentheses. Now we use union. And then we have 2 and 4 with parentheses. Okay? That was the very last problem in the entire section. Congratulations. We're done with the course.